We have that an NBA center recently signed a 7-year contract for $121 million. What is the present value of the contract given a 9% interest rate? In other words, how much must the ball club invest when the contract is signed so they can make 7 equal payments of about $17 million due immediately? What this means is that they want to pay him, they need to pay him this much per year, right? Because that is 121 divided by 7. So I'm just going to put 121 mil divided by 7 is that number right there. Okay? In the very first year, the very first payment, they're going to have to give him that much. All right? So they're going to need at least that much to do that first payment. But the next year, they can actually save for a year. So they won't need to actually have that much. They can have a little bit less as long as whatever they save, they start with, plus 9% interest gives them that much. This is why you don't understand things, because you're talking while I'm trying to explain. So, you can't just divide it and say, I'm going to give him 17 million. You can, but you're going to spend more than you have to. Because on the 7th payment, I didn't need this much. I could have a little bit less. As long as that last payment with 9% over the 6 years gives me that. Okay? So here's a way you can think about it. The very first year, you need that amount. Okay? Now, how much do you need to get plus 9% to give you that amount?
91%.
No.
Of the original.
It doesn't work that way, though. So what you would do is you want to get 17,285,714.29. You want to figure out what number you multiply by 1.09 to get you there. Does that make sense?
Yeah.
So to solve for that first year, I divide by 1.09.
That's not good to the 7 power though?
This is only for the first year. Okay? But yes, you're right. If I want to figure out what I need for the third payment, which is after year 2, I'd have to put a squared there. That'd be for year 2. Okay? So if I'm actually looking at my formula, and I'm going to stop using that big, huge number, I'm going to use 121 over 7 instead. I would have to take 121 over 7 and divide it by 1.09, okay, for each additional year. So that'd be my first year. That'd be my very first payment would be that much. My second payment I could have just saved that much. Okay?
The next would be 2 over 1.9.
The next one would be that much. Okay? So is everybody following where I'm getting these amounts from?
Why wouldn't you just, like the second year, why wouldn't you just do the one on top? The 17 million or whatever divided by.
This one?
Yeah,
That's this one right here.
it's the same thing. Why do you have to add it all up?
Because what I want to figure out is how much can I start with in the very first year, at the very beginning of the contract, how much I can start with, and then pay it out slowly over the years. Okay? So my very last term would be 121 over 7 times 1 over 1.09 to what power?
How many years?
It's a 7-year contract.
So maybe 7 time? 8.
6. It's a 6 because this first payment had an exponent of 0.
So that's the first year?
That's the very first payment. So you basically think about you're paying them before the year starts.
So it's like kind
So
of
sign the contract, here's your first year's pay, you work, here's your second year's pay, you work, third, fourth, fifth, sixth, seventh. Here's a seventh year's pay. And then you work. So that's your geometric sequence, or series, because it's adding. Okay, did everybody see where I got those numbers from and all that stuff? Okay, everybody understands why you need to do it that way.
Wouldn't that be 8?
Okay, so again, the whole point is I'm going to get an amount that's less than 121 million. My answer is going to be less than that, so that way I can put that into an account and pay out and I'm getting interest on that. And as I get interest on that, I'm going to add that to it, and I'm good to go. So, longhand, we could use sigma notation. Let's put that in there just so you know how to do sigma notation. Your sigma notation would be the sigma, okay, of our formula, which our formula is 121 over 7 times 1 over 1.09 to the n power. And my n starting at what? 0. And where does it end? 6.
Oh, that's how you know what numbers are.
So there's your sigma notation.
So 0, the end is where it starts.
Yeah, and whatever your answer is going to be in millions.
So where did the 6 come
Because that's the last
from?
term.
Okay.
That's the last number you plug in there. Okay, so now, longhand, this equals, all right, so we go back to our formula, which is the ugly formula, but we go 121 over 7. So we do our formula, our explicit formula. And how many terms do we have? 7 minus the first term.
Oh, okay,
Which is just the 0 power, right? And this is the tricky part. What are you dividing by here?
Minus 1.
Yeah, 1 over 1.09 minus 1. So, you basically have two ways that you could enter this into your calculator. Now, what I would do if I had this problem on my test is I would figure out my series here, put it in sigma notation, and use my calculator to do sigma notation to get me an answer. And then what I would do is, okay, that's my answer, because this is going to be ugly to plug in my calculator, right? So I'll just write that down if I want you to write down the longhand version. I'd write that down so that way I can see it, but just use the answer from your sigma notation. Clarice.
Why is that one to the 7th power now?
Because there are 7 terms.
Okay, but it started with 0.
Right, that makes it 7 terms.
0, 1, 2, 3, 4, 5, 6, 7.
But why'd you, wait, it stops at 6.
But that says 7.
Right, how many terms right here? You just said 0,
There's 7.
7 terms. That's what goes here.
Oh, the number of terms.
Yeah, that's the number of terms. Number of terms, first term. Okay, did anybody have an answer for that yet?
4,828,021.
Hold on, 94,828,000?
Yeah, 21. And then 3137.
Okay, so when you evaluate either this or that, it should give the same answer of 94 million. And you should kind of think about it in terms of the answer and say, okay, that makes sense because I want 121 million. It should be a little bit less than that. Not a lot, but that's a lot less than that, but not a, you know what I mean. It makes sense because that's 9%. Uh-oh. Okay, questions?